Sometimes you also want to remove the contaminants that are aesthetically unacceptable. They do not look good in the food products. So cleaning is very important, cleaning of raw materials. The second thing is that you may want to control microbiological loads and chemical and biochemical reactions that impair subsequent process effectiveness and product quality. So here we mean in microbiology, you study about the type of microorganisms that are found in food products, and some of these microorganisms are pathogens. And in some cases, it is important for you to be able to clean your raw material before processing in order to eliminate those pathogenic microorganisms, because you don't want to have them in food. In terms of chemical and biochemical reactions, so cleaning can also slow down those chemical reactions that would have taken place in the food product, so that it has a limited shelf life. So you want to clean so that in order your product can have a longer shelf life. So what is important to note is that the removal of contaminants is important for both, one, protection of the process equipment as well as the final consumer. In terms of the processing equipment, so we mean that in some cases you may have contaminants that can degrade your processing equipment. For example, you may have issues with certain chemicals that degrade the surfaces of your machines, or you can also have nuts, bolts, or even stems that can damage your equipment. So you want to protect your process equipment. The second thing is that you want to protect the consumer from getting sick, from getting ill, or even from dying. So food safety is very important in the food industry. The health of the consumer is very important. Therefore, cleaning plays a critical role in ensuring that the final product that you produce meets highest standards of quality. So this cleaning as a unit operation. So I want to emphasize here, because there's two types of cleaning that people normally refer to in the food industry. There is a cleaning as a unit operation, what we are discussing here regarding the raw material. So this is any cleaning that has got to do with the raw material. But there is also a second type of cleaning mechanism where it's based on the hygiene. So cleaning the surfaces of the factory, be it the floors, be it the walls, be it the equipment. So that falls under hygiene, and we are not looking at that at this stage. So if you were to be hired as a food scientist in the food industry, the question that will come is, what are the cleaning requirements that I need to know when it comes to this unit operation? The first one is that the separation efficiency of the cleaning process must be as high as possible with minimum wastage. So the ability of your cleaning process to remove the contaminants should be as high as possible. So if you apply a cleaning mechanism, it should be able to highly remove the contaminant and separate it from the products with minimum wastage of your product that or raw material that you are cleaning. The contaminant that is present in your raw material should be removed completely after the separation to avoid the contamination of the food product. So here you want to clean, and once the raw material is cleaned, so it should be, the contaminant should be removed. It should not be available in the surface. The design of these equipments that you have should be so as to limit the recontamination of the cleaned food. So your machines or your processes should be designed such that flying dust or contaminated wash water from previous batches does not come into contact again with the cleaned surfaces. And then this cleaning process that you apply in cleaning your raw material must leave the clean surface in an acceptable condition, right? It must be clean. The product must not be damaged after you've cleaned it, or the product must not have changed in its natural properties, and the volumes and strength of the effluent must be kept to a minimum. So, what are the types of contaminants that can be found in food products? Can you maybe take a guess? Just take 1 minute and think about what type of contaminants can be found in food products. We group contaminants in 5 categories. One is the mineral, plant, animal, chemical, and microbiological, which is the 5th, right? And under mineral, we look at things like soil, the sand, grease, glass fragments, metallic particles that can come into contact with your raw material. Under plant, we have things like skins, husks, and wood pieces that would contaminate your raw material. And the animal, we look at the excreta of the animals, hairs, feathers, insect eggs, and even body parts of animals. For example, you can have a leg of a cockroach in your polony or in your cheese, right? So that is regarded as a contaminant. So that will fall under the animal category. So you also have chemicals. So chemicals, this is a group that includes spray residues that are applied by the farmers, fertilizers, pesticides, and herbicides. So, according to legislation or regulations, these should be only be present at the required or minimum levels in food products. So you'd want to ensure that the cleaning that you apply, the cleaning regime that you apply, eliminates these also. Microorganisms and their byproducts. Of course, we know from a microbiological point of view that microorganisms can also produce products that result in different colors, flavors, and even toxins. Take for an example, onions. Sometimes you find that onions at home, if you've left them for a longer period of time, even at room temperature, they start to develop black spots as a result of microorganisms. Mold. So the color change, the black spots that you see, is a byproduct of what is happening in the onion as a result of these microbial organisms that are there in the surface. So now that you know these are the types of contaminants, so if you think, where could these type of contaminants gain an entry in the food industry? How can they come into contact with the product or with your raw material? The first one is the farming activities, how the farmers conduct their business at the farm level can introduce contaminants, be it soil, be it leaves, twigs, or even insects. And when the raw materials are delivered to the factory, remember we spoke of just-in-time delivery in the previous chapter, and also the transportation requirements. So immediately when the raw materials get into the factory, we can also have a situation whereby contaminants are introduced there. At the factory processing area, at the finished product store, wholesale and retail, things like Shoprite, Pick n Pay, Woolworths, etc., there can be contaminants that can be introduced in the product. So this shows that the whole processing supply chain, there is a possibility for products to enter your contaminants to enter your products. But you have more control of, we have more control of the raw material when it's delivered up until it's finished. Because once the product is at their wholesale or retail stage, you can no longer be able to clean it, especially if we are looking at packaged products. So, what determines the selection of the cleaning techniques or regimes? So the selection of any given cleaning technique depends on the type of contaminants that has to be removed from the raw material, the material being cleaned, and the degree of decontamination that is required. So now that we have this little bit of an understanding of the history or introduction, let us look at the cleaning methods that can be found in the food industry. So in terms of cleaning method, we are able to distinguish between two types of cleaning methods: dry cleaning and wet cleaning. So as you can see, the name dry means there is little of water or liquids that are used, and then wet cleaning means we use water and detergents and other chemicals to clean the food products. And therefore we will go through screening, and we'll also talk about aspiration, abrasion, magnetic separation, and also maybe look at some X-ray cleaning. So X-ray is basically an advanced technique. So what I want to highlight here is that these processes, both dry cleaning and wet cleaning, are normally used in combination in the food industry. It's very likely that you have a situation whereby both of these methods are used in the same products. As I've alluded earlier, the method, how you choose the method, is dependent on the nature of the raw material that you have. Is it berries that you have versus potatoes? So I can give you potatoes and then also give you berries, say clean these materials. At an industrial scale, you can't use the same techniques, right? Because the nature of the material is different. The other one has a softer texture and it's very sensitive, and then the other one has a very hard texture and it's less sensitive to mechanical handling. So the type of contaminants also to be removed is different. You may require to remove soil on one product, and then on the other you are interested in terms of removing either chemical contaminants such as fertilizers, pesticides, or herbicides. So the contaminants you removed are also different. And the last one is the desired condition of the cleaned material, or the degree of cleanliness that you want to achieve. At this stage, I would also like to add that peeling of fruits and vegetables, or cleaning of meat, or descaling of fish may also be considered as cleaning operations, because you achieve some level of cleanliness or separation of contaminants in your product or your raw materials. So now we are going to look at the cleaning of raw materials under dry cleaning methods. So what are these dry cleaning methods and what are their advantages? Right. So dry cleaning procedures are used for products that are smaller in size and have greater mechanical strength, and they possess lower moisture content, for example. Right? These dry cleaning methods are relatively cheap to apply, and they leave the cleaned surface in a dry condition, right? However, the disadvantage is that there's a possibility of dust recontamination, so the material can become dirty again. Care must be exercised or must be taken. The other thing is that dusty conditions could cause dust explosions as encountered in wheat milling process. So what happens here is that dust has the possibility to ignite or cause sparks, can result into flames, right, when it's comes in contact with the machinery. However, what the industry does in order to eliminate this is that they use dust proofing or dust extraction systems to minimize this kind of a problem. So under dry cleaning, we find the first unit operation, or the first method that we use, is screening. Screening makes use of size separators. Basically, these are sorting machines that are used as cleaning machines. They are able to remove contaminants of different sizes from the raw material. For example, when we're removing straws from cereal grains. So these screens are essentially separators based on perforated beds or washes, as can be seen in the figure, on the left here, we've got wire meshes, and these wire meshes can also be of different sizes, all right, and also different shapes in some cases. This is known, and also you have the perforated beds on the middle, and then on the left, on the far right, you have what we call screens that can be used at a laboratory setting. So what I want to highlight here is that on this picture here, or this diagram, we have screening of dry particulate materials. Figure A on top represents what we call scalping. What is scalping? Scalping is a process in the food industry whereby large contaminants are removed from smaller food items. And these includes things like cereal grains or pods and twigs from pears, right? And then what basically happens is that the rejected material has a geometric property which is completely different and even bigger than the desired material. And then the second part is when we have dedusting. So under dedusting, we want to separate the smaller material from the larger materials. So the contaminants in dedusting is having a larger size compared to the smaller ones. So you find that the unwanted contaminants are the small ones and the food units are the large ones. And then on the far right, we then have rotatory screen based on geometric properties. Again, these are basically screens that have the feet coming in, and then oversized materials, they come out on the other side of the screen. So these are rotatory screens. I will show more as we go along. So here we have what we call rotatory screens, rotatory drum screens. What are these? These are dromels or centrifugal screens that either do two things. They do two things. They retain oversized materials, the contaminant, and allow the desired cleaned materials to pass through and be collected. So in this case, there is brushes here in the middle where the shaft is, and then the stock, which is your final product, comes out on one end, and the refuse, which is the waste or the content, comes out on the other side. So we use these rotatory screens for cleaning products such as flour, sugar, and salt, right? Or the second mechanism can be retain the oversized material which can be desired and allow the undesired contaminants to pass through the screens and be discarded, as in the removal of weeds, right, and grit stones from cereal grains. So basically this is one mechanism which does two things, right? So in this example, you've got a different diagram here. The material comes in at 1, which is the same, containing both the contaminants and the products. And then at A, the material which is desired comes out, and at B, the material which is not desired comes out. So what happens here is that the material that needs to be cleaned, the material containing both the contaminant and the raw material, is guided through an inlet channel into the interior of the screening drum and is turned over there. So this drum is rotating because number 2 is motor that rotates there, right? So the grain then falls through the screen perforations while the coarse impurities are reliably directed into the outlet by a guided screw. So there's a screw that will then direct these larger materials into number B, right? So the coarse impurities are thus efficiently separated and the operational safety of the entire production system is increased. So this is another form of rotatory screen that can be used in the food industry. Okay, what you've just seen in the previous video is cleaning of wheat, which can take place immediately during harvesting, so that by the time the raw material, which is wheat, it reaches the processing area or the processing factory, it is already cleaned. And here what I wanted you to take note is that multiple screens can be used to remove contaminants, which are sticks or stalks that can be found in the product, the raw material. So in this case now we also have what we call flatbed screens. So these consist of one or more flat decks which are fixed together in a dust casing. So what you have here, we've got two screens that are present in the middle here. So one screen takes care of the oversized units, and then the other screen takes care of the undersized units. Right, so the whole assembly is shaken by an eccentric drive unit and is fitted with rubber taper bolts to reduce the clogging of screen apertures caused by the fine material. So the abrasion and impact caused by these moving beds could damage sensitive food products. So here, for example, you need to have materials that can withstand mechanical processing. So this type of process, which is flatbed screens, is used for fine materials such as flours and spices. Let us look briefly at the cleaning of corn, how the screening takes place. So corn can also be cleaned using vibrating screens, and so as you can see, so these materials varies also in size and also in capacity, can also be small, medium, and to large. We also now have what we call abrasion cleaning. So abrasion uses the abrasion principles between particles and moving parts, which loosen the adhering contaminants. So a clinical example here is the abrasion cleaning and peeling of potatoes. So each column here, or each segment, cleans the raw material, which is the potatoes, and it is able to remove the skin starting from the soil up until the skin of the potatoes as it rotates. So these mechanisms, these techniques uses trommels, tumblers, or vibrators and rotating brushes which can be used. So an example of abrasion cleaning is removing the husks from roasted peanuts. Sometimes we normally wrap them between our hands, you know, if you eat those roasted peanuts. This can also be done for removing hulls around coffee beans. So these systems can also be used in conjunction or in combination with aspiration cleaning methods. So we're going to look now at aspiration cleaning methods. What are these aspiration cleaning methods that we are talking about? So when it comes to aspiration cleaning methods, so I'm going to first start by looking at just basically the simple, and then we're going to look at the more complicated diagram. So what you need to understand here as a student in terms of aspiration cleaning is that this technique focuses on what we call the aerodynamic properties of the food and the contaminants. You still remember what the term aerodynamic means. We've met this term before on the raw material and the process. Aero means air, hydro means water. So here we are using the aerodynamic properties of the food and the contaminants. So it is widely used in cleaning of cereals, but it is also incorporated into equipment for cleaning peas and also beans. So what is the principle? So the principle is to feed the raw material into a carefully controlled upward stream. So there is air at the bottom here. So this air, what it does is that it drives, it's driven by, for example, fans, right, at a controlled velocity. So the raw material and the content, in this case, they will have different densities. Let's say the product has a higher density compared to the contaminant. Because of gravity, gravity is going to pull the denser material down, so and then it goes out, while the material that is lighter is going to be pushed away by the air. So this is used in cleaning of cereals and nuts, also peanuts. It can also be used for cleaning onions, melons, eggs, and some other foods not suitable for wet cleaning material. So this, what you see here, is just a one unit or a simpler unit. We can also then find more complicated units which have got different or various streams, right? So as this is what we call a SOX-TEX air separator, which basically removes these materials based on their aerodynamic properties. When you see the wet aspiration cleaning, you should also just click aerodynamic properties. So now let us go and look at the magnetic cleaning. The end is nigh. So magnetic cleaning uses permanent and electromagnets are used. So these can be located above or around food conveyor belts in processing. So electromagnets have an advantage of that they are better to use since the removal of adhering magnetic particles are affected by stopping the electrical current. So these magnets are usually followed by metal detectors in the food industry that monitors the materials for both ferrous and non-ferrous particles. So these detectors generate a magnetic field that is distorted by the presence of materials. And again, electromagnets are easy to clean just because you can then just turn off the electrical current or the power off, then we are able to clean it. This disturbance, if there's a present ferrous or non-ferrous particles, it signals a disturbance which signals an alarm or activate a rejecting device. We then also have what we call electrostatic cleaning. So this is a very interesting one because now we're just coming aerodynamic properties which uses density. So in some cases you may have a situation whereby the shape and the size of the contaminant and the raw material is the same. How do you clean that? So you can't use screens because the shape and size are the same. So what we then use here is that we use the surface charge, right? We look at the surface charge because the surface charge of the contaminant and the raw material may be different. So this principle can be used to distinguish grains from other seeds of similar geometry but different surface charges, as I've said. And it has also been described for cleaning products such as TEAM. So the feed is conveyed into a charged belt. So this charged belt rotates, right? So this charged belt is positively charged and it continues to rotate. So these materials, same with the contaminants, then they go down and then there's an electronegative negative electrode over them. So materials are then rejected or are then channeled based on the surface charged. Materials that have a lower surface positive charge will go into one stream and a higher surface charge positive charge will go on the other stream. The other technique that we can find is the X-ray separation. So in this case, the product is passed through a fluorescent screen. So normally they used to have an operator detecting the inclusion of microcontaminants dependent upon the transparency of the products or materials. So then the examples of X-ray separations, handling of eggs, looking at contaminants inside egg products to see if there is any contaminants that can be present there. And then they can also use it for screening of filled wine beverage bottles. And at SAP, they used to have an electronic bottle inspectors, which they were called EBI. This can also be used for cheese inspection. All right, let us see how it's being used to look like. So this is the olden system, and then this is the latest system that they use. Right, so what we've just seen here is basically X-ray cleaning of the material. So they have already been cleaned, so the system detects any contaminants that can still be present. So there is a bottle that has been programmed, so the machine uses a pre-programmed bottle which has been cleaned previously, and it takes us of each and every passing bottle that passes through. If there's a bottle that is different or there's cracks that are detected, then these are rejected, as you've seen with one of the bottles that was rejected there. So this is the end of part one, which is now what we call the drying methods. Then part number two is going to look at the wet cleaning methods that can be used in the food industry. So what is important to note here is that the type of contaminant that you have in your products, the type of product that you have or raw material, desired outcome or degree of cleanliness determines which cleaning method we are going to use. Thank you.